So today we will continue with the Project Euler series, and I believe the last problem we did was problem 9. Let me just check. Problem 9, yeah, this is what we did. And let me just shut this down and let's create a new problem. So we have solved this problem and we want to solve maybe one or two. It's going to be a short video today. So we are going to solve this problem, which is the summation of primes. Earlier, I think we had a problem that had to do with the summation of primes, some sort of primes. So let's see, multiples, largest prime factor, there you go. And this is where we had a sieve algorithm. Is this a sieve algorithm? Check for prime. No, largest palindrome product. It's not this. Okay, let's look at some square differences. There you go. One 1001st prime, whatever that was, and we had calculated the primes up to, what is this, 5 million, and it happened in 7.32 seconds, and we need to calculate the primes to 2 million in this case. So I think we can just copy paste quite a bit of that code over there. Okay, so let's look at this. Let's call this problem 10 like that, and let's copy the problem. This is problem 10. There you go. Problem 10, and this is called the summation of primes. So we need to find all the primes all the way up to 2 million. 2 million. Wow. Like that. Find all the primes up to 2 million. And then just add it up. So it's not a very difficult problem. Let me just copy this first. So we'll get a list of primes over here. So yeah, let's copy this. And we want 2 million. I don't know what this is for. There you go. And that's 2 million. Let's start with 10, because 10 is something that we can easily calculate and make sure that our numbers are correct. So we have this. Okay. And we have our primes. We have to import numpy. Okay, let's do that. Import numpy as np. Okay. And let's do this. 3 milliseconds and it's done. Okay. It's because we are looking at the first 10 primes. So the first 10 primes are 2, 3, 5, 7. 2, 3, 5, and 7, and the sum of that is 17. like that. So we need to get that number. So instead of going up to 10, we need to go up to 2. Is that a million? That should be a million. So if we solve this, it will take about 7 seconds. I don't know how long it's going to take. It should take less than 7 seconds. Let's wait and wait and wait and wait and wait. Is it 2 million? Is that really 2 million? What was this over here? That? This was 500,000. Okay. So maybe we need to go in stages. Okay, so let's do one thing. Let's go up to 500,000. Okay, 500,000. So this should finish in 7 seconds or so. I think it should finish in 7 seconds. There you go, 7 seconds, and we have the primes. So there are 41,000 primes, and we want to continue here from this 500,000 number. So let's start with this, and we are going to do the same thing, except we are going to start from large n, like that, and then 2 times large n. So this one, large n plus 1. Wait, this is going to be interesting. Give me a sec. Let's do it for 10, and I want to see. Okay, I want to see what this is. Okay, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now if what is large n to 2 into large n, 10, so I go from that number. I don't want 10, I want plus 1, and I want large n over here. So I go from 2 to large n plus 1 to 2 into large n, and so on. Okay, so that's what I want. Okay, now nums become equal to that. All right, and what I want to do is do the same thing, but before I do this, I want to get rid of all the other prime multiples of the primes. So for p in primes, okay, we are not going to add this in primes, okay, but what we are going to do is we are going to reduce nums equals nums percentage p is not equal to 0. Okay, so what this is going to do is get rid of all the things within nums that are not part of the primes that we have already seen. And then after that, we are going to do this like that. And now if we see nums, okay, nums is no longer this, and if you look at primes, or if I can spell primes, we will see that all the prime, these are all the prime numbers all the way from 1 to 20. And we can now say two into large n plus 1 to 3 into large n plus 1. Okay, we can do that. And if we look at what nums is at this moment, okay, we go from 21 all the way to 30, and we do that. We look at nums, and we do that. We look at nums, and the primes are those things. Okay, so we have an iterative solution that we can go over. So let's take a look at something where large n is equal to 50,000 or 500,000. This will take approximately 7 seconds to do. There you go. So we will have a set of primes. Okay, and if we look at nums now, we will see that it's an empty array. But if we look at the number of primes, we have a ton of primes. So the next thing we want to do is we want to go from and we'll call this I, and we'll call this I plus 1. Okay, so now we are going to go from 500,001 all the way to 1,000,000. Okay, so we have these nums. We get rid of everything that is already a prime. So we have 41,000 primes. We update number so that all the prime factors within that are gotten rid of. We look at how many are available now. There are 36,000 of these available. So we want to find all the prime factors within here. Okay, and let's take a look at that. It's going to take a while, but 36,000. Okay, it finishes fairly fast. So now let's look at nums, and we have more primes, 78,000 primes. Okay, that's very cool. Now we go from 1,000,001 to 1,500,000, 1.5 million. We should go over there. Let's see. There you go. We have, wait. Oh, this is not right. There should be I, like that. Okay, so now we go from 1,000,000 to 1,500,000. Okay, let us get rid of all the multiples of the primes that we've already seen. Let's wait for that to be done. It should take about 22 seconds. Okay, not bad. How many numbers do we have left? 35,000. Let's find the primes within here. Okay, so we should have no more nums in the nums array, and we should have more primes within there. So we have 114,000 primes. Okay, so we have gone all the way up to here. We need to go one more, 3, like that. So now we go from here all the way to, I hope this is 2 million. So this is where we should be. So we are basically collecting all the primes over here. Let's collect the primes. And we take some pistachios. While solving the problems. Okay. Let's see if it finishes in 20 seconds. It should finish in 32 seconds. Okay, not bad. 32 seconds. Now, let's see how many numbers are still available. 34,000. Let's get rid of that. And we have 149,000 primes. And if we sum this, wow. Okay, let's see if this is right. I have no idea. All right, we have solved this problem. Okay, how do I? Okay, where do that? Okay, thanks. So we have done this. All right, let's do one more problem, then we'll call it a day. Okay, so this problem 10, new notebook. Okay, let me save this, close this, close this. Yeah, let's close these things. Shut down. Okay, let's go to here, and this is problem 11. Let's call this problem 11. All right. Largest product in a grid. Okay, problem 11, largest product in a grid, and in the blah blah blah, let's copy paste this first. Just here, like so. I can't color with red, but never mind. Okay, so problem 11. In the 20 by 20 grid below of numbers along the diagonal, we have been marked. That's been marked in red. The product of these numbers is 26 times 63 times 78 times 14 is equal to this ridiculously large number. What is the greatest product of the 4 adjacent numbers in the same direction, up, down, left, right, or diagonally. Okay, so 4 adjacent numbers. So we take 1, 2, 3, 4, and then we take 1, 2, 3, 4 like that. It doesn't matter whether we take left to right or right to left, because obviously a product is a commutative operator. So we only need to do it this way first, and then this way, 1, 2, 3, 4 like that, and then we need to do it diagonally. Okay, let's get to work. My favorite tool, import numpy as NP. I'm not sure whether we're supposed to use numpy, but never mind. Okay, let's get the numbers into an array. Numbers is like that. Okay, we do that, and then we do dot split, and nums will be, wait, what the hell is this? That's not what we want. Oh, wait, this is good, I like this. Okay, you know why? Nums equals list map int nums, and nums equals np dot array nums. Dot reshape 20 times 20. Okay, let's look at nums. All right, we have an array that is 8 to 22 all the way up to 8, 91 and 8, 49, 49, 99 all the way up to 0, and at the very end 1, 70, 54 all the way up to 67 and 48. So we have the right array. Now we need to slice and dice. All right, for I in range, let me just 16 nums I to I plus 4, and let me just print this. Oh, wait a minute. And we'll say j is 0. For j in 0 dot, let's just 1 j all the way to j plus 4. Okay, so we have 8 to 97, 8 to 54, 8 to 52, 1, 2, 3, 4, that's correct. Okay, so, and we have a square array. print like that. Okay, so we have a square array 52, 70, 95 and 95 and 23. So that's an array, and we go 49. Okay, so we go down like that. 49, 49, 99 and 40, and then we go all the way down to 49, 81, 52, 22. Okay, so it goes all the way down. The last one is 88, 4, 20, 20. Okay, we need one more, right? 17, 4, 20, 21, 4, 20, 21, and that way. Okay, what we want is the product. What is the greatest product of four adjacent numbers? Which one it is doesn't matter, but it should be the greatest product. Equals 0. Okay. Right from here we can calculate three products very easily. Okay, two products very easily. These are numpy dot product. I think numpy has a product function. Yeah, there you go. Axis equals 0. P1 equals that, and P2 is that. Okay, and this is axis equals 1, and let's print P1 and P2. All right, so we have ridiculously large numbers, this, and this, which is the horizontal products and the vertical products. So we have four products. We only care about the maximum of these things. Max of P1 plus P2, like that. Okay, so that's if you look at it, 1, 5, 3, 9, whatever is going to be one of these. Not correct. List and list. These are numpy arrays. List like that. So 950. This one is the biggest. All right. Okay. And we also have a diagonal, and we only care about the main diagonal because the other diagonal will, this diagonal will be taken care of by, so 49, 49, 95, the next one will be taken care of by the next one. So we just need to find the diagonal element. So the diagonal element, diagonal, and np.diag, np.diag, this, that one. This stuff, that stuff. if we print this, let's see what we get. So we have 8, 49, 31, 23, and we should get the product of this and put it through the maximizer as well. So we should get the np dot, we want the entire, oh, what the hell happened here? Okay, we want the entire product. That's, we'll call this B3. Like that, B3 is that. And let's print B3 as well, B3. And can I do this? Can I, let me do this first. M1, M2 equals max of M1. I don't want to take the maximum between a list and another value. So P3, whatever is the maximum, if the greatest product is less than this M2, product equals, and we carry on. Okay. So this one we are going to call it temp equals that. They should all be temp. Temp should be temp. This should be temp. I am willing to bet that this will give you just print the, we have to go the other way as well. Okay. Why is it printing all of this stuff? Oh, there's a print statement over here, and there is some. So 35 million, I guess. 358. Is 3 million. Okay, so we have to do the same thing for J, like that. No point in printing all of this stuff, so let's comment this out and comment this out. And is this the number? I don't know. Let's try and see. No. Oh, it's a different number. So we have to put in a little more work. We have to figure out why we did not get the number, right? And we have to figure out why we did not let's print this and see how many we have. And we did. That is the exact number that we put in. Okay. There is one thing I forgot to put. That is the other. So we have this diagonal, this, and this. And we forgot to put the other diagonal, this, and this, which also happens to be diagonal. Let's look at temp. Okay. Temp np diagonal is that. So that's temp, and the diagonal is 4, 40, 4, 5, and this one. I also need the other diagonal. I bet let's transpose 44, 5, and 40. We are not going to get it by a transpose. Okay. Temp rows 3, 2, 1, 1, 0, and 3, 2, 1, 0. Will this give me that idea? 48, 5, 4, 40. 48. That's not what I want. I want 0, 1, 2, 3. 0, 1, 2, 3. 36, 36, 57, 89. That's what I want. That's what I want. Like that. np dot p4 is that, and I also want p4 like that. What the hell just happened? I have a bigger number. That's fine. Let's check. All right. Okay. So we have solved 2 problems, and today we will call it a day over here. Let me see, my other code is still running. Why don't we do one more problem? Okay. This is problem 12. Highly divisible triangular number. Maybe we'll leave it for the next day. Okay, so problem 11. I will stop over here and we will continue on the next day. Okay, bye-bye. And this will be uploaded to YouTube. If you're watching on YouTube, please like and subscribe if you like these videos, and take care.